Here's a good physics problem illustrating how to solve a physics problem. It reads, a car started from rest and accelerated through a displacement of 100 meters. If the car's final velocity was 20 meters per second, how long did it take? And what was the car's acceleration? Okay, let's take a look at the solution. Okay, so the car started from rest. So that is a piece of given information. So I'm going to write the original velocity is equal to 0 meters per second. The car accelerated through a displacement of 100 meters. So the displacement of the car, delta x, is equal to 100 meters. If the car's final velocity was 20 meters per second, so that's a piece of given information, 20 meters per second, how long did it take? So they're looking for time. And B, what was the car's acceleration? They're looking for acceleration. Now I am going to assume that the acceleration is constant. So you notice I didn't put an average symbol on top. That should also allow us to use equations that are only valid for constant accelerations. All right, let me draw a diagram. A diagram is very wise to include in your solution because it helps the reader of your solution better understand what each one of these means. Okay, so I'm going to show the car at the beginning of the story as an original velocity v(O). Here it is at the end of the story with a final velocity given as 20 meters per second. And I'm going to draw an arrow here pointing to the right where the length of the arrow is supposed to be proportional to the magnitude of the final velocity, which is 20 meters per second to the right. So there we go. We're looking for time, and the way I would like you to show time is put a parentheses like this, and then write delta t. So that shows that there's a time interval going from here to here. And then last but not least, we're looking for acceleration. The acceleration occurs during this time interval. So write A, and then draw an arrow pointing to the right. Now this arrow and this arrow represent two different vectors. So they do not have to be proportional to each other. The length of this arrow is supposed to be proportional to the value of A, and the length of this arrow is supposed to be proportional to the value of df. So I think you can see that it's really arbitrary because we really don't have anything to compare to. I could actually have made this any length and this any length. Okay, the next step is to write down an equation which will allow you to find one of the unknowns. And I think we'll start with delta t. You don't always have to do that though. You could start with this one. But let's start with delta t. And if you look at what we know and what we're trying to find, you can see that since it's a constant acceleration, we can find the average velocity by adding these two velocities together and dividing by 2. And we know the displacement. So the displacement divided by the time is equal to the average velocity, which is, as I said, original velocity plus final velocity divided by 2 equals, and then delta x over delta t. Okay, so now we solve for time. So we get 2 times the displacement divided by the original plus the final velocity. So that's 2 times 100 meters divided by 0 meters per second plus 20 meters per second. So we get 200 meters in the numerator and 20 meters per second in the denominator. So that's equal to 10 seconds. So it takes the car 10 seconds to undergo a displacement, of 100 meters. All right, now let's find the acceleration. Well, the acceleration can be easily found using the equation, final velocity minus original velocity divided by time. So we have 20 meters per second minus 0 meters per second divided by the time, 10 seconds, and we get 2 meters per second squared. So there you go.